we will apply Kirchhoff's laws to this problem here. So according to the question, it asks you to find the current that flows through the 8 ohm resistors. So where is your 8 ohm resistor? Your 8 ohm resistor is here. Now, what is the current which is actually passing through this 8 ohm resistor? So to know that, so we will discuss in this way. Let us imagine that the current which is produced by the cell having EMF 4 volt, let's say it is I1, and the current which is produced by this EMF 6 volt, let's say it is I2. Now this I1 will flow across 2 ohms, I2 will flow across 4 ohms, and after that they will combine and they will move across 8 ohm resistor. So the current across 8 ohm resistor will be I1 plus I2. So here we have to know how much is I1 and how much is I2. So for that we will apply Kirchhoff's voltage law. So applying Kirchhoff's voltage law to the loop, suppose I will name this is point A, B, C, D, E, F. So if you apply Kirchhoff's voltage law to the loop A, B, E, F, A, okay, A, B, E, F, A, and as well as to the loop C, B, E, C, B, E, D, C. So now we have two closed loop or two closed circuit here. One is A, B, E, F, A, which means along like this. Another is C, B, E, D, which means along this direction. Now, so now because we have to find the current across 8 ohm, and across 8 ohm we have two unknown quantities, that is I1 and I2. So because there are two unknown quantities, so therefore I need to consider two closed loop, that is the first loop and the second loop. So if you apply the Kirchhoff's voltage law across the loop A, B, E, F, A, then look here what will happen. Because the current which is passing across 2 ohm resistor here, it is I1. Now the path choosing or the path traveling across this 2 ohm resistor, it is from A to B, because you are considering AB, AB. So therefore the potential difference or the potential drop across 2 ohms will be positive, which means it will be 2I1. Similarly, after ABE, right, BE, the path traveling across 8 ohm resistor is from B to E, so the potential drop across 8 ohm again will be positive, which is 8 times the current, which is I1 plus I2. And after this we have EF, and from in right along this path EF we have no resistance, and now we are going from F to A, but from F to A we have 6 ohm resistor. So therefore the potential drop across this 6 ohm, because you are going across this is from F to A, so the potential drop across this 6 ohms will be positive, so which will be plus 6I1. So these are the potential drop across the different resistors in this case in this closed circuit. And all the the algebraic sums of all these potential drop across any resistors, it should be actually equals to the algebraic sums of the EMF in that closed circuit. So in this closed circuit A, B, E, F, A, we have just one EMF, and that is 4. And when you look carefully at the directions that we are traveling across this 4 ohm, it is A, B, E, F, A, F, A. So when you go from F to A, that means you are going from negative to positive terminal of the cell. So if you are going across the cell from negative to positive, then we know the EMF will be positive, right? Okay, so we write for that as just 4 only, it is not minus 4. So next what I will do is I will remove the bracket. If you remove the bracket, you'll get like this. Okay, Now combining all the similar terms like I1, you'll get 2I1 plus 8I1 will be 10I1, and combining, sorry, I made a mistake, this is actually I1, so 2 plus 8 will be 10, 10 plus 6 will be 16, 16I1, and plus I2, we have just one term, so we write 8I2, and this is equals to 0. Okay, now what I will do is I will divide throughout these equations by 8. If you divide this by 8, you'll get 2. If you divide by 8, you'll get just I2, and this is equals to 0. So we name this as equation 1. So similarly, applying this KVL to the loop CBEDC, CBEDC. So now you are going right across this resistance 4 ohms. It is from C to B. So from C to B, the potential drop across this 4 ohms will be positive, and the current across this 4 ohm, it is I2. So therefore, next you will have potential drop across 4 ohms will be positive, that is 4I2. And next CBE, along BE, the resistance is 8 ohm, so this will be positive. I hope this is clear. And after that, the next resistance is, after BE, you are going down to ED. Along ED, we have no resistance. Now from D to C, there is 1 ohm resistor, so therefore I'll write plus. What is the current here? It is I2, so 1 times I2 will be I2, because the resistance is 1 and the current is I2, right? So you'll get I2 only. And look at the EMF. The EMF is going from D to C, which is from negative to positive terminal, so the EMF will be positive, that is 6 volt. So just like before, I will, as you know, remove this bracket. I will get 8I1 plus 8I2 plus I2 is equals to 6. Or I can say, if you combined, right, this I1 is just one term, this is 8. Now look at I2, we have 4 plus 8 will be 12, 12 plus 2 will be 13 I2. So right hand side is equals to 6. Okay, I think there is a little mistake over here. This is actually not 0, but it should be 4, right? So if it is 4, then this should be 4. Okay, so here I should not divide by 8, but I have to divide by the, HCF among all the 3 numbers, 4, 8, 16, it is 4. So dividing by 4, you'll get 4 here. Dividing by 4, you'll get 2. Dividing by 4, you'll get 1. Okay, so now from these two equations, I will solve how much is I1 and how much is I2. So I know, right, that you have done in class 10 about elimination method while solving x and y. That means in linear equations of 2 variables, right, we solve them. Actually there are many methods, but I prefer the elimination method. So in elimination method, what we have to do is we have to multiply the equation 1, right? Suppose I want to eliminate I2, I have to multiply equation 1 by the coefficients of I2 from equation 2. That is 13, I have to multiply equation 1. And similarly for equation 2, I have to multiply by the number 2. So if you are doing that, right, if you solve equation 1 and equation 2, then I will just write down the answer. You will get here this I1, right? If you eliminate I2, then you will get I1 after solving equation 1 and equation 2. Okay, you will get I1 is equals to 1 upon 36. So how do we get I1 equal 1 upon 36? This is your homework. Just solve equation 1 and equation 2 by elimination method. You will get I1 is equals to 1 upon 36 ampere. Now once you are getting this I1 is equals to 1 upon 36, then we will substitute the value of I1 in equation 1. So if you substitute I1 in equation 1, then you will get 4 times, instead of I1, I will write 1 upon 36 plus 2i2 is equals to 1. Now this 4 with 36 can be cancelled, right? And 4 times 1 is 1, 4 9 are 36. So again, simplifying this equation, you will finally get I2 is equals to 4 upon 9. Now, after knowing I1 and I2, then you can determine how much is the current passing through 8 ohm. So therefore, current through 8 ohms resistor will be how much? I1 plus I2. In place of I1 you write 1 upon 36. In place of I2 you write 4 upon 9. Again, this is like from class 6 you have done this, right? So I hope you know how to find out the LCM. So when you simplify this, you'll get I1 plus I2. I will just write down the final answer. It is equals to 17 upon 36. And if you divide this number, you'll get 0.472 ampere. Okay, so the current that is passing through 8 ohm resistor, in this case it is 0.47, or approximately this can be saying as 0.5 ampere. So this is how we solve the circuit problem using Kirchoff's laws. Okay, so I hope this video is clear to you, and if you have any question regarding my explanation, please do feel free to ask me a question through my WhatsApp number, or you can send the question to the WhatsApp group also, it's fine. Thank you very much.